Hello all. Today I'm starting with inverse trigonometric functions and we will plot today a graph of sine inverse x. But before we get into that, let us get into a unit circle. We must understand the concept of a unit circle, which is extremely important in trigonometry. And a unit circle is a circle with radius 1 unit. That means this coordinate will be x and this will be y. So the x coordinate is 1 and the y coordinate is 0. Similarly here a minus 1, 0, 0, 1 and 0, minus 1. We all know this is 0, pi by 2, pi, 3 pi by 2 and 2 pi. That's a 360 degrees. Any point that we plot is taken with respect to x and y coordinates. So if this is x and this is y and this is the radius r, then any point is plotted like x and y, and this is an angle theta. Looking into this circle, I can see here that cos theta is equal to base by hypotenuse and sin theta is equal to perpendicular by hypotenuse. So what will this imply? This is going to give me x is equal to r cos theta and y is equal to r sin theta. Now we know that in our case the radius is 1 and therefore the first value will always give you cos and the second value will always give you sine, because the radius here is 1. So I know that cos of 0 is 1 and sine of 0 is 0 and cos of pi by 2 is 0, sine of pi by 2 1, and same ways it goes throughout the unit circle. Now let us construct a y is equal to sin x looking at this unit circle. So what happens here is I'm going to plot the angles, which is a 0 and in terms of radian pi by 2, pi and 3 pi by 2, 2 pi and so on. It goes, the values repeat themselves after 2 pi radians. This side if I was to take a minus pi by 2 and a minus pi and so on. You can see here the sine function lies between minus 1 and 1. So does the cos function, it lies between minus 1 and 1. So we are taking here a 1 and here a minus 1. Now let's look into the graph. We know that sine of 0 is 0 and sine pi by 2 is 1, sine pi again 0, sine 3 pi by 2 is minus 1, 2 pi 0. So if I join these points on either sides, I will get a graph like this. If you notice that I don't have to lift my pen, it's a continuous graph. So y is equal to sin x is a continuous function. And now what happens over here is, for a function to have a inverse, what is the basic requirement? It should be both 1, 1 and an onto function. For a 1, 1 function, we look into a horizontal line test. A horizontal line test will tell us this is a horizontal line test and it should cut only at one place. We can see here that the graph is being cut at multiple places. So what happens? It fails the horizontal line test and therefore it is not a 1, 1 function. Not a 1, 1 function, and therefore the inverse does not exist. However, in a restricted domain is what? The value of x. If I restrict the domain, where? From a minus pi by 2 to pi by 2, only this part. You can see these horizontal lines are cutting only at a single place. Let me just plot it and show it to you. If I was to draw this graph at one place, so if I draw this like this, so this was a minus pi by 2 and this is a pi by 2. So if I was to plot it like this, and now I draw horizontal lines, you can see here they are cutting only at one place. So I am restricting the domain, alright, and therefore in a restricted domain the inverse exists because it is cutting only at one place. So what is the domain? Domain is the value of x, which is a minus pi by 2 to pi by 2, and range is the value of y, which is what? A minus 1. Let me write it properly, which is a minus 1 to 1. Domain is the value of x and range is the value of y. Now you must know that a horizontal line test will tell you whether it is a 1-1 function. A vertical line test will tell you whether it is a relation or a function. So if it cuts only at one place, it becomes a function. If it cuts horizontally at one place, it's a 1-1. And if it cuts vertically at one place, it becomes a function. If it cuts at two places, it becomes a relation. Coming to the inverse, so now we are plotting y is equal to, let me write it properly, y is equal to sine inverse x. What happens over here is x becomes y and y becomes x. So basically this was what? This was x is equal to sine y. An inverse function means we are having here interchanging. X becomes y and y becomes x. So as far as the graph goes, the graph which was looking like this will now become like this on the y-axis, and it will move like this. Okay, and therefore you will see that whatever was x now becomes y, and whatever was y will now become x. So y was what? Y was minus 1 to 1, and x was here a pi by 2 and here a minus pi by 2. So this is the graph of y is equal to sine inverse x. And now we can see here what is the change. The domain here, that's the value of x, has now become minus 1 to 1, and the range has become minus pi by 2 to pi by 2. If I was to combine both the graphs, this one and this one, let's see what we will get. And the first graph was looking like this, and I combine these. And just to show you that if I was to draw a line in between, the line passing through the origin is given by y is equal to x, and this is the line which is at an angle of 45 degrees. You can see here I get mirror images, and you know that I am only looking into this part. We've already shown the restricted domain in both the cases, and therefore this is the graph of sine inverse x. I hope you've understood the concept. So in the next video we can discuss cos inverse x.